Hi guys, we hope you are doing well at home. The other day we did an air pressure demo and we hope you enjoyed it. Today we're going to do a little bit more with air pressure. We're taking air pressure to the extremes today. So the other day we blew a ping pong ball out of a cup and we blew a ball into the air. Today we're going to put some objects in some extreme air pressure conditions and watch what happens to them. You guys are going to be our scientists at home, making some observations on what you notice while we're doing this. So the first thing that we have today is a vacuum pump. So if none of you guys are familiar with a vacuum pump, what happens is I have this jar, it has air in it right now, but when I turn on this machine, the air in this jar is pulled out. It starts sucking out of the jar. So eventually there is very little air in this jar, if any. So we have a deflated balloon inside of our jar right here. And I just kind of want you guys to take a minute to think about what is going to happen to this balloon when we take all of the air or most of the air out of this jar. Do you think it's going to squish the balloon down and make it crumple? Or do you think it's going to blow the balloon up? Or do you think it's just going to kind of stay the same? I don't know. Take a minute to think about it. All right, junior scientists, are you guys ready to experiment? Here we go. What are you noticing? What's happening to the balloon? Is it doing what you thought it would do? Or is it doing something a little different? We're going to let it go for another minute or a little less and see if it keeps getting bigger. All right. So what happened? I think we all noticed that the balloon grew bigger. It inflated when it was in that vacuum. So that might seem weird. Why, if you take the air out of a space, would the balloon get bigger? Well, what's happening is in normal conditions, air pressure, surrounding air pressure is pushing in on the balloon. So it's keeping it kind of small and deflated looking. And whenever you take the air out of the space around the balloon, the air pressure is gone. Nothing's pushing in on the balloon, but the air inside the balloon is expanding and pushing out on the outsides of the balloon. So instead of getting smaller and crumpling up or staying the same, the balloon expands and it gets bigger inside that vacuum. Did you know that astronauts who do spacewalk in outer space, they actually have special pressurized suits to help just with that, because outer space is a cold, airless place. So you definitely need a special suit before you go on a spacewalk to fix anything on your space shuttle. All right, so that's one extreme. We took all of the air out of that one. Now we're going to do a demonstration where we add air pressure. So right now I have a soda bottle that is about, it's a little less than half full with marshmallows. And I drew a little black line here so that we can indicate where our marshmallows are when they first start. On top of my bottle, I don't have a regular lid. I have what's called a fizz keeper. So fizz keepers are usually used on soda bottles or carbonated bottles. You can put them on your carbonated beverages and pump air into your carbonated beverages and keep them a little bit fizzier longer. But today we're going to use it for science purposes. So we have our marshmallows inside of our sealed bottle, and I'm just going to use the fizz keeper to pump some air into the bottle. Now, what do you think is going to happen to the marshmallows when I add air? Do you think they're going to expand and get bigger? I don't know. That's what happened when we took away the air. Or do you think they're going to scrunch down and crumble a little bit with that extra air? I don't know. Let's experiment and find out. I can feel the bottle being very firm. There's a lot of air in there. Give it a couple more pumps. A couple or 10, whichever. All right, so here's our line where our marshmallows used to be, and now our marshmallows have gotten squished all the way down here at the bottom. And you'll notice they look a little wrinkled. They look like they've been aged a little bit. Or they kind of look like after dinner mints, if you know what those are. So they're definitely being crushed in there by the weight of, or by the pressure of the air. Pretty neat stuff. So we also know with this that there's a lot of air in this bottle, right? So we're gonna watch what happens when we take this off. Use your sense of hearing and maybe your sense of sight to watch what happens to the little top when we release that air pressure. Woo! Did you hear that? It made a nice whoo kind of sound. And you notice that I pulled it away from my face and kind of closed my eyes a little bit, and I'm wearing my goggles because occasionally when you take this off, it will pop off. It'll act like a rocket and pop because the air pressure is so strong. But now you can see that we have this off, that our marshmallows are kind of back to normal. Now, they're marshmallows, so they've kind of taken the shape of the bottle. So if I dislodge them a little bit, fluff them back up, they go right back to where they were when we first started. So air pressure's pretty exciting stuff. Especially when you put it to the extreme. So in review, when you use a vacuum to suck the air out of a space, it kind of makes a balloon expand and grow bigger. And when you use air pressure to add air to a space, it kind of crushes the marshmallows down and under the pressure of all that air. All right, guys. I encourage you to do some of your own air pressure experiments. If for some reason you do have marshmallows and a soda bottle and a fizz keeper and you try this at home, please follow my lead and tilt it away from your face when releasing the air pressure. You do not want to get whammed in the face with a fizz keeper. It is not a good time, I promise. All right, guys, it was so much fun experimenting with you today. Go out, observe the world around you, be scientists, and have a great day. We'll see you soon.